second part of what I'll talk about is just a bit on peroxidation. As you'd expect, or as the literature suggests, the more double bonds you get, the higher potential is for peroxidation. Depending upon who you look at is the rate of that peroxidation relative to some older data here, or some data that a little more newer at the rate of peroxidation. Peroxidation it's complicated, but I've simplified it because my mind's kind of simple. You have your unsaturated lipid. You can get a free radical either from the ATP process or outside forces generating a free radical. This free radical will react with this hydrogen to give you a lipid radical. You peel off water. More oxygen, you'll get a lipid peroxy radical. This peroxy radical can react with another lipid. Peel this off as water. This goes back to a lipid radical. This goes to a lipid peroxide, and it can be further processed, chain cleavage, etc., into aldehydes, ketones, acids, or if you get enough of them, they can get polymers together. That's the generalized concept. What to measure is another question. It's a ever-changing process. We put this in the NRC. This was kind of my introduction to this. First, you generate peroxides, PV value. Those will get degraded. You go into some of the volatiles, the acids, the aldehydes that will come off. Ultimately, you can get free fatty acids forming in terms of peroxidation. Some of your polar compounds can be, some of the aldehydes are polar or they're non-polar. And you can get polymers. So this is kind of a simplified. A lot of components going on there. What to measure? Depends who you are, depends who you talk to. We're probably most familiar with peroxide value. Those measures peroxides, hydroperoxides. There's other things you measure there. You probably have seen T-bars. T-bars measures compounds that are similar to malondialdehyde. Anisotine value is more of a conglomerate of aldehydes. And then you can get into some specific aldehydes. I've gotten into this relative to some of my work with the University of Minnesota. And you can have predictive tests. That is, how much more can it be peroxidized, or how much is left. So if you have a high PV value, in theory, you would have a low OSI. So they kind of go hand in hand. So what to measure? That's a question. It's going to vary with, as you'd expect, your fatty acids or your fatty acid components. And does it really matter? What can we relate it to? A little quick detour when I was thinking of temperatures. If you think of, I remember when I started this, what's the temperature of grain bins? Grains or feeds in grain bins. This is where I came up, maybe the 45C for a week or two. The process of corn milling has some heat involved in it. And at least in one sample that Minnesota published, they did have one sample of distillers that had a high PV value or high T-bars value. Animal rendering has temperatures associated with it. Of course, fat tanks got to keep heated. Whether you drain those fat tanks or not can be iffy, how long it sits in there. So there's a temperature, time and temperature associated with that. Your yellow grease, your restaurant grease, not only is it processed or used as a temperature, but there's processing on that. The only data I could find on a survey was from Theo van Kampen back in 2002. And in that case, they got some PV data, free fatty acids, and then some AOM numbers here. So here's an indication where, here's the average number and here's the range. Is this high or low? I can't tell you that yet. Here's the case where you had free fatty acids. People are saying, well, that's got to be bad. We worked with a local feed mill on their analysis once. This was their data. And their comment was, all fat's the same. This is cheaper, so it's just as good, right, Dr. Kerr? I'm like, I don't know. Because some of that product was color of your skin. Some of the product was as black as coal. But it's all the same. I'm like, let's think about this a bit. The history of working on peroxidation and lipids is varied. I started working with the Minnesota group because they got a food division group. Within their food science department, they were looking at the greases from McDonald's, Burger King, Arby's, things like that. And Augie Solani would find these compounds in there and she'd say, those are toxic. Those need to be discarded in the landfill. Of course, we're like, well, wait a second. We feed these to pigs. She came unglued. She goes, you're feeding this toxic compounds to pigs, which we're eating? I'm like, we live on byproducts. So there's a lot of discussion there. The group at Kansas State worked on some choice white grease. There's a lot of variation in methodology here, which again is a challenge. The K-State group used choice white grease, heated it 80 C for up to 11 days. This was their type of system here. They bubbled in oxygen. Nova supported some work at Illinois and Virginia Tech with corn oil, corn and soy oil both, a little higher temp. This was not a consistent 72 hours. They only heated it during the day. So heat it, cool it down, heat it, cool it down. Eric Van Houten, again, soy oil, 80 degrees. Here was Eric's first system here. He used oxygen. They used air. And some more work of Eric's was in a larger tank here. In this case, he used air. We were initially funded by the Fats and Proteins group. We incorporated this 95 type temperature, but also 190. 190 is frying temperature, by the way. And then we went down and looked at various products here, canola, corn, poultry fat, and tallow, in a system where, in some cases, we used your little vats like this versus my current system here. So looking for a method. Quick scan of literature. Peroxidized lipids can decrease performance, largely due to feed intake. You can have some lipid metabolism effects. You may or may not induce oxidative stress. Immune response, not much data there, but basically nothing. Intestinal integrity, you say it was a less poor gut function there. But really not much data there. In a review that Jerry Sherson's student did, Andrea Hansen, for part of her PhD thesis, she went through the literature, looked at basically fats, not looking at the fat that's in a product, but added fats. Reviewed the literature. The variables of interest were peroxide value and T-bars, and then performance. Here's their data set. The top is just individual comparisons. The bottom is really the correlations in poultry and swine. In terms of swine, the regression was with T-bars. So a change in T-bars affected performance. In poultry, it was peroxide value affected with performance. If you look at the papers I reviewed, the papers only looked at peroxide value and T-bars. So if you look for one thing, you're only going to find one thing, maybe. Then I kind of argued with Jerry a bit on this. I go, if you delete one data point, things change. If you eliminate a couple data points, things change. I reviewed this paper for the journal. It's always fun to do that and then hear the author's response. So the challenge we had was is peroxidation an issue? Can we develop a method that is somewhat consistent in generating peroxidized oil to be a challenge? We've worked with corn oil. I was influenced by Jerry. I got over that. So here's a time series analysis of 95 degrees or 190 degrees. So this is for, say, 72 hours. This is for just 12 hours. And you can see that in this case, oxygen stability index goes down, kind of a mirror image of peroxide value, opposite image there. And you can see at this temperature, some of your aldehydes start going up. This doesn't show it too well, but it's always interesting to see some of the colors that change in some of these oils. Color is kind of a meaningless number, just to to plug that in there. When it had a higher temperature, you can see that oxygen stability index dropped immediately. You see no change in peroxide value because basically that goes away really fast. We don't even show up when I measured the oil at 1 hour. And then you can see a couple of these aldehydes. And you can see kind of a darkness here. One thing I don't have, it doesn't show up too well, is this one. As you cook at a really high temperature, it starts getting viscous. So viscosity goes up. We did this method of cooking in these 150 liter aluminum vats, either with a immersion heater, and we bubbled air in the system at about 12 liters a minute, or in the case to get to 180, we had to use a turkey fryer. But again, we used air for that. Everybody's like, why didn't you use oxygen? I go, oxygen and open flames is not what I want to do. The swine farm is old, but I don't want to be the one to burn it down. We've conducted 3 projects on this. The same cooking person, I was the fat cooker. So we had a control, uncooked, a 45 degrees for about, this is about 14 days, 3 days at 90, and 6 hours at 180. The goal of these different time temperatures is to get a different profile of peroxidants. That's what the data is for. We didn't know what to measure. We could have just measured peroxide value at, I think it's only cost me like 30 bucks a sample. It's pretty cheap. But we didn't know what to measure. The aldehydes is what the University of Minnesota Food Science Department is interested in. Because if you read the human literature, 4-hydroxynone now, HNE, is the most detrimental aldehyde for DNA damage. So this is one they talk about quite a bit. A company looks at Hexnow here in the Midwest, and it's always interesting that hardly anybody looks at tocopherols. What's your best source of tocopherols? Soybean oil. So as you cook them, you can lose tocopherols. 3 trials, nursery grower finisher pigs. This is Stephanie Lindblom's master's work. This is Martin Overholt's Ph.D. thesis. Kind of some of the system there at Iowa State. This is the work I did with nursery pigs. We got some response. Again, a treatment response is not really what I'm looking for. What I'm looking for is how do the peroxidants, do they relate to performance? So I can give you guys a number that high PV does this. So we measured all these. This was just simple correlation. We're still trying to put all the data together. But it's kind of interesting that peroxide value does show up in correlations to performance. Nicotine does in starter and grower pigs, not finisher. We had polar compounds measured by my ARS location in Peoria, because they were interested in soybean oil and polymers for the industrial industry. And then we looked at some specific aldehydes. The goal is to put all these together, because really that's what I'm trying to get to on this. When Martin worked on this for me, at least in the grower and finisher pigs, he really couldn't get a multivariate analysis to have them all in the same experiment. Surprise, surprise, growing pigs reacted to the peroxidation process different than finishing pigs. The other thing on this is, it's one of these hindsight things. How much vitamin E did we add to the diet? Do we add the basal level, or were we 10 times that? I can tell you on these experiments we're a shade high, about 3 or 4-fold NRC. So based upon this, and things not working quite together, I redesigned a new project. More cooking levels. Just like amino acids, if you have a greater variation, you should be able to get a better curve. Some numbers are the same, so you see a 180, you see the 90. I did some splits in here. I actually got up to 225. The flash point of soybean oil is close to 235. first time I cooked this. For those of you who've been to the Iowa State facility, the Discovery hallway is about, what, 8-10 foot high? I had 4 foot of smoke in the whole hallway. I thought I was burning the building down. So to try to maintain a temperature for that, I did some other changes. The initial studies were, and I'm not a physicist, we pumped out air out of a 3/8 inch copper line from a small vacuum pump. That's one big bubble. So we drilled smaller holes in the line to make smaller bubbles. Smaller bubbles is more surface area. And I got a bigger pump. So instead of 15 liters a minute, I'm up to 30. Typical Kerr study, 10% inclusion, broilers with 7.5. This is the preliminary data on that. It's always fun to look at colors. Here's your temperatures. You can see the temperatures. The 67.5 was just a pretty color, by the way. And then this was pretty black as coal. So either chicken study, pig study, the reason I'm putting both up is to bring this out. Same type of system. Gain response, feed intake response, feed efficiency response. That in birds, up to this point, we had very little impact on performance. We had performance impacts here. In pigs, we had a performance response at the 90. So up until this little hiccup in the government, I was getting ready to analyze this data on correlations, things like that. We've actually repeated the study in pigs because I want more data for the correlations. I recooked oil, I did some blending and things like that. But you can see in some of these cases, I think we have a model to where we got a gain here of about 65% of the control, feed intake and feed efficiency. So I think we got a model from which to test now to feed graded levels of this to find at what level depresses performance. So it's again one of those things, is it no impact and then impact, or what that might be. That's what I'm up to lately. Again, concluding thoughts, we've got energy is a cost. It's variable in the ingredients. We need to figure that out to get our competitive advantage, to take advantage of alternative ingredients. The challenge is how to design the research to get at some of these answers. And how to design, and it's not going to be a one and done process, but how can you design multiple experiments, assuming you get the right logic, that I can give you an answer on, this is how we need to tweak the energy equation. This is what we need to think about relative to a peroxidation index of the animal based upon which peroxidant or thing like that. That's kind of what I've been up to lately on some of the thought process.